Hi everybody. First of all, I would like to thank LASCON for inviting me to speak here today. I'm really excited to talk to you all about the wonderful world of application security. I know what you all must be thinking, another boring, dreaded work seminar on application security. Well, I'm here to reassure you one thing, that my presentation will not bore you, and second, if you keep your mind open, you will be challenged in a good way. Before we start, I would like to share something about the whole purple teaming philosophy. Some point in my career, I happened to be one person application security team. So I had no choice but to mix the blue team and red team expertise together to help my developers way early in STLC. And I was actually inspired by Daniel Meissner. He's basically he's at IO Active right now. He writes this wonderful security blogs. So in one of his blogs, he explained the importance of having blue team, red team, and they really need to work together instead of fighting with each other, so that we'll have more collaborative, effective results. So I took that concept and I'm like, if I have to apply this concept to application security program level, what do I need to do? So this presentation is all about my experimentation. All right, let's get started. That's a little bit about me. All you need to know is security is not only my paycheck, it's also my passion. And the agenda for today's talk is we are going to talk about some challenges that we basically face in order to make our application security program successful. One of the big challenge I have seen is there is this negative stereotype around security professionals, and security testing. Second thing, no matter how strong processes you weave around, our security processes always sound immature. We are always one step behind those developers and architects who wants to use the latest, greatest technology stack. And the third one, it kind of goes in the same line. I have seen the security tools that we select are kind of incompatible or do not provide full coverage to the entire technology stack that these developers use. The main goal of this presentation is how can we reduce the overall risk using these methodologies? How can we actually improve the return on security investment for program initiatives, something like purple teaming? And third one, how to weave security not only in the STLC, but in the business as well. And we can talk about solution approach as we proceed. I will make these slides available, so you guys don't have to take photos or notes. All right. In my last 8 to 10 years of security careers, everything negative I have heard about security testing, and security professional, I have put it here. I really want this session to be interactive, so feel free to stop me, ask questions. I don't want this to be a monologue. How many of you heard that security is a bottleneck? Raise your hands. Cool. How many of you heard that the checkpoint approach is considered a watchdog approach, a cop approach? Yeah. How many of you heard security is hard, complex, difficult to understand, and expensive, especially those pen testing? Cool. How many of you heard or got into argument with your development team that, hey, my application doesn't have any sensitive PII data, so security is not essential? So most of the stuff is true, which is, yeah. This one is my favorite. Security is hindrance to innovation. Yeah, and the fact is, we security professionals work so hard so that your innovative ideas can be implemented in a secure ways. So we are not here to create hindrance to security, but to support you guys in a secure way. So Let's accept one fact. As Carla Harris said, she's a Wall Street veteran, a very famous public speaker, and author of zillions of books. She said it, perception is co-pilot to reality. I want all of us here, all the security professionals to admit to one fact that these are not just mere accusations. There is some fact associated with it. There is some reason there are so many negative stereotypes around security. And as we proceed with the presentation, I really want you to think, what can we do to help ease this negative stereotype? Before jumping into the core topic of purple teaming, I want all of us to take a step back and let's focus on application security elements. Let me ask you a quick question. What constitutes to a good, successful application security program? Anybody? Oh, by the way, I forgot to mention those 3 questions, which I find challenging. I'm going to give away books. So please ask questions. Let me read the quote for you guys. If you think technology can solve your security problems, then you don't understand the problems and you don't understand the technology. Rushnaya. 5 years into my career, fascinated with cryptography, I literally used to think that cryptography, if implemented correctly, can solve any problem. And over the last 3 to 4 years, I realized, no, it's not. There is always a weakest link which can be exploited no matter how perfect your technology is. So to answer the question that I asked previously to you guys, information security is never just about technology. It's about selecting and implementing right technology, building efficient processes around it, and it's all about connecting to people so that we all together can take informed decisions. So let's start with people. Is there anybody who does not belong to InfoSec here? 1, 2, okay. Just to be clear and to be safer on my side, these blue team and red team in security world has nothing to do with the blue team and red team we see in American politics today. Just to be safe. So blue team usually is the internal security team which helps developers, architects, selecting, designing those controls, security controls, defensive mechanisms. And red team is usually external, sometimes internal as well if you work for a big company. They basically beat shit out of your application using exploitation technique so that they can find as many security flaws as possible. So this is another motivation. I'll go over it very quickly. So this is economics of fixing security bugs. If you see, end of the day, security bugs are actually software bugs. We call them vulnerability, but when it comes to fixing, these are defects and bugs. So these are 2 independent study conducted. One is by IBM and second one is by NIST. These are a little bit older references. I couldn't find something new, but if you look at it, you can see in design phase or in requirement gathering phase, the cost of fixing bug is 15 times smaller than the cost of fixing bugs in maintenance or production phase. So that's a really good motivation. And if you think carefully, when do we do penetration testing? We do penetration testing because they are so expensive, we can't do it every now and then. We do it once a year, at the max twice a year, when the product is ready to move into production or it's already in production. If you haven't done it or your customers are not happy with the results, then they will go hire third party and they will do it. And at that time, the security issues identified, it's very difficult to fix it. Now, one caveat, I'm not talking about those security issues which are easy to fix. I'm talking about major security issues which require design or architecture change. So don't take it literally. Okay, back to our teams. So we are not going to just talk about mixing the defense with exploitation techniques. We are also going to talk about their personality traits. So blue team folks are the optimist folks who generally think the glass is half full. And red team folks, who are the pessimist folks, they think the glass is half empty. And what it means to a purple team member, he or she is basically a realist who thinks the glass is full, 50% with air and 50% with water. Very optimist, fact oriented. Just to think from a different perspective, think that the blue team and the red team folks are sailing and they're in the middle of storm. The blue team guy thinks that he's optimist, right? So he thinks, oh, the storm is going to pass and my boat is sturdy, nothing is going to happen, and we have life jackets and my data is secure somewhere, so nothing is going to happen. But things do happen. On the other hand, the red team member, who is the pessimist one, he thinks it's just a matter of time, the boat is going to sink. Doesn't matter what we do, it's going to sink. Now, what does a purple team member think? So purple team member studies the direction of the wind and he adjusts the direction of the sail to minimize the impact. He prepares for the worst and hopes for the best and makes necessary adjustment. So that's the philosophy a purple team member needs to have. Does anybody have any question? No? All right. Let's get into process. Are there any penetration testers here? Great, because I do have 2 to 3 core technical examples, so it's not just boring AppSec program talk. Just hold on. All right, I'm going to read this really nice quote by Bruce Schneier. Security is a chain. It's only as secure as the weakest link. Security is a process and not a product. Again, going back to what I said, it did take me 5 years to realize that security is not a product. You can't just throw a bunch of crypto stuff there and assume everything is secure. You have to make sure every link associated with security is secure. So let's talk about processes. What do we see in today's world is this is how security is integrated in SDLC. The top one is waterfall SDLC, the bottom one is agile. At different companies in different groups, we see different SDLCs, we see combination of both, whatever. Security assessment stays the same. In requirement gathering phase, we kind of do threat modeling. In design phase, we do design architecture review. In development, we do static code review. In testing, we do dynamic app testing. And in deployment, we do internal, external penetration testing, right? In case of agile, technically everything should happen as per the mapping. That is, in requirement phase, we should do threat modeling, and in development 1 and development 2 phase, we should do static code review. But I have not seen that, to be very honest. I have seen all sort of security testings are happening here. Once the alpha, beta, whatever product release is ready, that's when the product team approaches security team. And then we try to do everything in 2 or 3 weeks window for them, because they don't come to us, because they don't have anything concrete, right? Security is expensive, like it or not. So let's see what are the advantages and disadvantages of doing security this way. So that was the classic checkpoint approach. The advantages are this model has been around like last 8 to 10 years. It's very, the engagement is very streamlined. It works well for waterfall as well as agile. Now when I say agile, only the major releases. That means we can afford to do this only once a year. If we try to do this for every minor release, it's not going to be possible because their schedules are just so aggressive. Third one is checkpoint approach is really good at blocking insecure deployment. You know, the expectations between development team and security teams are set. We tell them, hey, If we find high and critical, and if you don't fix it in this given SLA, we are going to block. We are the cops. We are going to block you. So that works well. Then vulnerability statistics and metrics are well defined. This particular approach, or whatever findings, the developers don't fix it, we enter it in a risk management. So the risk management process is also very well established. Now let's take a look at what are the challenges we usually see. If these assessment methodologies are not communicated in, well in advance, and if they do not have allocated timeline in sprints, then we see that it slows down the deployment process. The development teams are not happy with us because we are just doing too much. So communication is very important, and if you don't do that, especially if you look at their sprint schedules and the way things change in Agile, it's very difficult to predict something that is what will happen 2 months, 3 months down the line. Next one is, if you think carefully, the more focus is on assessment. We are just doing bunch of assessment. We are not even talking about what are the security requirements of your product or what security principles are absolutely must for your product. We open the dialogue with the development team with threat modeling. So this is definitely not a holistic approach. Of course, this is integrated in SDLC, but is it really integrated in your business? No. That's my next point. Security is not weaved in the business process. And again, if you want to, when we do these type of assessment, we do it for that snapshot of a time. In the month of May, we will do all this. The code that will be shipped in July, it may not have undergone all these assessments. So this is, like, practically speaking, it is impossible to do these assessments for each and every release. Next one, our most popular, famous continuous integration, continuous delivery model, where, pretty much same thing. It's just that developer likes to commit the code 30 times a day and they deploy it. So what I have usually seen is, shift towards the left. We kind of empower developers with right security tools and technologies, and we give them basic security knowledge and whatnot, and come to us if you have questions. So I've seen that static code analysis plugin is usually integrated in IDE. So the idea and expectation is the developer, whenever he commits code, he should run a static scan, right? But how often a developer really runs a static scan? Not that often. We really need to work with developer on frequency. Hey, at least do this once a month, once a week, or whatever it is, depending on the sprint. So that rarely happens. Then what I have seen is bunch of security configuration checks during build trigger. Yeah, that's really awesome. Finally, we are actually integrating security in the build pipeline. Really, really awesome. But is that sufficient? No. We are covering some portion, not everything. And then in testing phase, of course, we provide them with different DAS tool. They run DAS, they fix something. We really don't have control when they are moving so fast. So yeah, finally, when the product is about to get out in production, security team comes in and they try to do their due diligence. Whatever was not covered, we try to do more stuff. But it's still not mature yet. Good folks like Matt are working hard towards integrating security in CI/CD. It's a big challenge. I don't understand. I mean, if a SAST is going to take 1.5 hours or 3 hours, how we are going to implement that as part of each build process? It's just impossible, right? Or DAS takes longer time. It's not possible. We can definitely say run Docker CIS benchmark the hardening check in like 2 minutes, and that works well. But if we have to do a thorough security assessment, how we are going to do that? So basically, I have worked with my developer, negotiated with them. Hey, can you do that at night? Can you do that at weekend when you have longer time? You certainly don't need to do this every single time you commit code. So that sort of thing. Okay. Yes.
So if it's a microservice,
Yes.
100 plus applications,
Yes.
how do you think that's possible?
It is not possible.
So
I do have example down the line, example that contains microservice oriented application. We need to look at security in a different way. This is all is like assessment to gain assurance so that a security baseline is established. It's like we go to a doctor for annual checkup every year, right? To get assurance. He can perform blood tests, urine tests, he can see some stuff, how my skin looks like, how my smile is, but that's assurance. When we get results, that's assurance. Is that really security? No. I mean, is that really health? No. Health starts with eating right, sleeping right, exercising. That's really health. What we get from doctors is assurance. So please understand, all the assessment we do is assurance. It's really not security. Of course, we get the security baseline and we find flaws and then we fix them. Yeah, but that should not how it go. That's not holistic. It's more reactive. Even though we insert in early stages of SDLC, it becomes proactive, but it never becomes holistic. So I'll get to your question when we discuss that example. So what are the challenges when we do secure DevOps style assessments? I have received initial pushback from DevOps engineer. They don't want to do this. They don't want to integrate all these different security tools in their build process. It definitely slows them down. They don't always necessarily see the value at the beginning. Second one is, we really need to be careful about selecting security tools for them. If the tools do not match with their technology stack, we are wasting their time and our time. If the tools have a lot of false positive rates, they hate it. They don't want to use it. There is a reason there is a negative perception around security tools and technologies. Next one is these DevOps engineer, they have to go through a learning curve. So, and general product security issues and what are false positives, what are false negatives. And most important, not everything can be automated. I know DevOps is all about automation, write scripts for this, that, but human interaction is required. You want to do manual penetration tests, you need a human. No matter how expensive smart tools you get, they can ever match human. And of course, the security requirement analysis and design architecture review, we need humans for that. Unless somebody has developed automated script, let me know. How are we doing on time? Okay. So let's talk about purple teaming approach. So purple teaming is really not here to replace any existing AppSec methodology, that is the checkpoint or secure DevOps, but it is there to augment. As I said earlier, checkpoint methodology or secure DevOps, they establish this basic security baseline, right? Now if you want to take it to the next level, we have to think it in a slightly different way. So purple teaming philosophy, it starts with, your engagement starts with your development as training. You want to train your developers not only about secure coding guidelines or OWASP top 10, we actually want to teach them what are the basic security requirements that your product should have, what are the security controls around it, what are the different attacks and exploitation techniques. Because no matter how good job a blue team, how the blue team does, the penetration testers always find flaws. So there is definitely something missing there. So while designing security requirements, if you consider exploitation techniques, you end up deploying or designing or deploying more stronger and refined controls. And I have a few examples just in like 2 slides. So you start with training, teach them about exploitation and not just secure coding guidelines or defense or OWASP top 10. Second thing, once the training is over, you sit down with your product teams and try to map their business requirement with their security requirements, so that security is weaved in a business. If they see not fulfilling this security requirement has impact on business, you will get their buy-in very easily. They won't argue with you. Next one, in design phase, as I already said, do not focus just on control. Do think about exploitation techniques so that you can implement stronger controls. Let's see. So these are some of the key aspects of what I was telling. In the first column, you will see 10 security principles: confidentiality, availability, integrity, identification, authentication, authorization. You can club them together as access control, but I like to keep them separate because identification is different from authentication. Identification is associating user's identity with his credentials, with his account. Authentication is associating that user, validating the user's credential. And authorization is, of course, figuring out whether this particular user is allowed to do this task, although he's authenticated, or he's not allowed to do that, and so on. The one thing, one security principle which I see missing in most of the product is privacy. We are so big on behavioral analytics that we tend to forget this thing. So, and then after 4 or 5 releases, suddenly it becomes a big issue. I really don't know, is it my soothing voice or it's the time of the day that some folks are sleeping? When my security career is over, I do plan to become a meditation teacher. So this is actually a good thing. Do not get offended. Anyway, back to security stuff. So this is one example. Security requirements are usually derived from these principles. And I have just picked one example. Authentication. Session IDs should be sufficiently long, random, unique, across the correct active session base. There is one word missing here, and it's the crypto nerd inside me. The requirement should be cryptographically secure random number. When I was a developer, I used to develop mobile casino games, so I used to use random function a lot. And 10-15 years back, I had no clue what is the difference between random number and secure random number. And 5 years into, or 3 to 4 years into my security career, I had no clue the difference between a secure random number and a cryptographically secure random number. So all these things matter, and it's our duty to teach our developers what is the difference and what are the real threats out there. When it comes to cryptography, the real threat is foreign governments, who has army of 60,000 hackers, fully equipped, highly skilled, lot of supercomputers. So that's our real threat, not script kiddies, not pen testers like us or security researchers. So literally, if you keep a phone in a dark room, it will, and do not touch it at all, it will not get any entropy. But it's a single user device, so it's basically unusual. You probably don't need a random number generator, something that is so stable, just FYI. Okay, so we talked a lot about entropy. So what's the security control? The development team has selected this particular method which generates session ID, and it's actually from the underlying framework. Great! The framework is already selected because it is latest, greatest, cutting edge. Performance point of view, great, and usability point of view, great. So security point of view, oh, we don't have time to think. It generates, it looks random, right? They pass random number through digest, so it passes the check. Now what happens 2 years down the line? When the product is out there, some security researcher who has a team of 5-6 students, days and night, do entropy analysis of your product, find the entropy is actually not 128 bits, but it is 80 bits. Ooh, big flaw. Then you go back to your engineering, you go back to your security team and redesign. So why not think about exploitation techniques that real security researchers or foreign governments use way early in SDLC when you are creating your business requirement and mapping with that's going to create that's going to generate a lot of cost saving for you. Just imagine fixing this really big security issue down the road. So that's the whole philosophy. Gone are the days when we start involving pen testing teams right before production or after production. Let's think about all that way before. It's a cultural problem again. Yes, like we need to advocate. We need to get rid of the negative perception and show us real value to all the stakeholders. We need to make this as a win-win situation for everybody. Yeah. Actually, I have a few slides. Yeah. So before getting into the whole AppSec program and what are the different phases, let's little bit talk about the foundations of positive security. Remember, our main intention is to get away from the negative stereotype about security, security professionals, and security testing. I genuinely feel if we don't have to fight with our internal stakeholders about including security proactively, holistically, and we don't have to fight with them about fixing security issues, half of our battle is done. Like half of our job is done. Like we can literally focus on fighting against the real threats, foreign governments, researchers, hackers. So it's very important to improve that culture, and some of these things will help. So first, invest in your stakeholders to build a foundation with security knowledge. How do you do that? With security training. Internal security trainings are the best way to open a dialogue with your development team. Second, empower all stakeholders with appropriate security tools and technology. Don't hold on to those security tools and technology just to yourself or those exploitation techniques. Give it away. Teach security to everybody through training. I have said this again and again, map your business requirement with your security controls, and when you're designing with your requirements and when you're designing controls, do keep in mind those exploitation techniques so that you can design and deploy stronger controls. This one is very important. Speak the same language as SDLC. No matter what SDLC you are using, waterfall, agile, CI/CD, the security team needs to become part of the product team. We need to use same tools and technology that they are using. Do not use RSA Archer for logging findings and risk if your team is using Jira. Create your security tickets in Jira. For some reason you are using something else, say Salesforce, then integrate your Salesforce with Jira so that it's not a double work for them. And that's absolutely important. If you are using Agile and your product owners want you to work with them on creating stories around a security requirement, go ahead, do that. Speak the same language. If they have sprints and dedicated release managers, go work with them. Next one is very important. Create that win-win situation for all the involved parties without compromising security. Does anybody have any questions? Yes.
So, if you have a large development shop, your security team is usually not as large as
Yes.
the development shop. So, how do you deal with the lack of resources?
So what I started doing at my previous employer was I started having brown bag sessions, like once a month. Then I started doing twice a month. That was my way to open a dialogue. More and more people were interested, understanding security and exploitation. And I would not just teach them secure coding guidelines, but exploitation as well.
But are you democratizing to the app teams to do their own risk assessments and that, or do you
that will eventually happen, right? First we need to train them, because no matter how many AppSec professionals are out there, we are never sufficient. The company I work now has 25,000 developers, I believe. So anyway, I'm not supposed to talk about that. So it always starts with training. Make them interested, bring free food, that always attracts a lot of developers. And make security fun. Free food always works, oh man. Developers never plan for their lunch and whatever.
I work in finance and I'm going to give us free food.
Ah. Well, you need to talk to your CSO. Followed by, hold on. Once training sessions are over, kind of encourage them to hack their own products. And maybe, end of 6 months, 9 months, you can arrange a private bounty program. Of course, you need your upper management's buy-in, some money for, creating those type of events. So you definitely need money. Yeah. So private bounties are great. The only thing is you don't want teams to fight against each other. So you need to be really careful. But these nerds, developers, introverts, they love competition. So teach them security techniques, exploitation through training, and make them do real hands-on stuff. I always think about worst thing what can happen. Just to give you example, I got 2 laptops, my personal MacBook, and if something goes wrong, I have my Windows. So I always think about worst, I prepare for the best. Does that answer your question? Okay. All right, so this is how a typical AppSec program looks like. We usually start with creating application inventory, then we have some engagement plan, followed by assessment, all sort of things, and reporting, remediation, and metrics. I'm going to go in detail, and we will have those technical examples which contain microservice-oriented architecture in like couple of minutes. I'm not going to spend too much time on this, but basically we have to have an inventory of all the applications, internal facing, external facing, then applications that acquired through mergers, acquisition, third-party applications, component, microservices, this, that, deployment, everything. That is our first thing. Second thing, we need to create a profile of each application based on the description, functionality, technology stack, interfaces, components, microservices, so that we will come to, and of course the highest data classification, so that we'll come to know the business criticality of the application, so that we can focus, out of these 100 applications, these top 20 are the most important one. I want to knock them down this year, and then I can focus on next. Next one is your engagement model. As I said 100 times, always start with internal security training. Now there are, you can do external security training if you don't have folks internally available, but internal security trainings are always good because you kind of start building relationship with your development team. Like they don't look at you as external threat. So that's always nice to have. And again, don't just teach the attacker's mindset, teach them the exploitation techniques. That's where the real value is. Product onboarding, I've already repeated that, so I'm going to skip. All right, so in your training, how are you going to teach both the things? Controls and exploitation techniques. This is a simple file upload functionality we see in almost all web applications. So when I'm wearing the hat of blue team, I usually have this design architecture questionnaire that I go through when I talk to developers about their products. So I see, file upload functionality. So I tell them, hey guys, allow only authorized users. So definitely do a check around authorization. Then check for the file size. Make sure nobody uploads a gigantic file because that will take down the server or whatever. Then look for the file extension, and please use a whitelist approach. This is our favorite thing. Security professionals are crazy about whitelist, and it does work, right? You only focus on those 5, 6 extensions, and you don't have to worry about creating a huge blacklist. So it always works. And of course, run antivirus on your server. Now, 3 months down the line, when the product is ready for internal pen test, I'll wear the hat of red team person, And I'll try to bypass the authorization by checking if there is any loophole around function level access control. Are they using flag? Are they using this? Is there any implementation flaw? Whatever. Next thing, I will try to manipulate the magic number and the file extension. So I'll take exe file and I'll change the extension, make it what doc or .txt and try to upload it. And it works because they never check the magic number in first place, right? Because I never told them. I was the same person. But my metrics are derived based on how many findings I get, right? As a pen tester, I need to have as many findings as possible. And then I'm like, wait a minute, I'm a same person, I work for the same company, and why I'm doing this? It's in best interest of my company, my development teams, and myself to teach them everything way beforehand. If that's the technique I'm going to use, why not tell them way ahead so that they will pass all these different gated security checks smoothly. Their path to certification or compliance will be smoother. That's where I see a lot of value, and that's when I started doing it. Was time saving for me as well. And you do that with one team, you create a few security cases in Jira and just apply it across all the product portfolio. So it saves a lot of time. And when I say purple team approach, of course, when we think about security requirements, we think about attack, and these are my security test cases and positive test cases. We don't think about those abuse cases, those negative test cases way early. We start thinking about them when we are in testing phase. So do think about those abuse scenario way early. That's what I meant. And one fun thing I did is my product team passed the pen test with flying colors. In a genuine file type, I added a bunch of cross-site scripting injection. And what I realized is they did not perform input validation on the content of the file. They were just checking the extension, the magic number. And the whole thing resulted in a stored cross-site scripting, a persistent cross-site scripting. So I started teaching them about all these creative way of doing things. And one more thing I noticed is two of the allowed file types were .log and .txt, and they actually do not have any magic number associated with them. So how does your white list approach is going to work? That's where you have to apply hybrid approach. You have to have a whitelist and a blacklist of not allowed magic numbers or extension. So what we think in design phase, whitelist is awesome, that's what you implement, doesn't work when you start exploiting things. So you really have to think from that perspective, because against whom you are protecting your product? Those real life hackers, thousands and thousands which are out there. All right, finally I have a microservice oriented architecture. We all love this. And CI/CD fashion, you can see 20 plus microservices here. How many of you are aware of blind cross-site scripting? Good. For those who don't know, blind cross-site scripting is actually a variant of persistent cross-site scripting where injection is uploaded via one interface, but we do not see the response in the same web application. We see it somewhere else. In today's world, we have these microservices which are being used by different applications. So you can see injection was inserted in application 5, but actually application 1 was affected. We really do not have the control how the value in a particular parameter was passed around and whatnot. So here the security controls are input validation and output encoding. We know it, we do design architecture, threat modeling, security requirement analysis, whatnot for application 5, because that's the main critical application. What about other applications? And this is a typical CI/CD scenario with microservices. What do we do? So here my take is, take a look at security from a holistic perspective. If the bunch of microservices are being used by other applications, we have to put them on a document as well. And we really have to look at each interface. The requirement and controls are clear. How I'm going to test this? By inserting cross-site scripting injections in all the data stores. This is more related to money. What is your budget? Can you use that IST technology for all the 5 applications, or are you planning? Yes, it's very expensive. Is SAST and DAST more, is it less expensive? And another thing I realize is that IST technology supports only Java, .NET and JavaScript. These guys are developed using Python. So it doesn't have full coverage. It's a neat idea. I have a lot of respect for innovation in security, but it's not there yet. But all your applications have the same technology stack, go for it, and you have budget. Yes. So the way we have static code analysis where we run automated scan, and the way we have dynamic application security scanning capabilities using commercial scanners like HP Web Inspect, IBM AppScan. Contrast Security has merged both the technologies together. The problem with SAST is there are too many false positive or out of context findings. So if you have time, go through each one of, knock them out, which ones are true positive, prioritize. In case of dynamic web application security scanning, you don't always necessarily get all the coverage, like it doesn't go all the way deep down. It usually happens at interface level, and again, same problem, lot of false positive, false negative. So what interactive application security testing tools they do is, these are agent based. They sit in different deployment environment at server, on developer's box, here and there. Great value, great idea. And they kind of mix the results from static, because it has access, the agents have access to code, as well as it has ability to dynamically perform security testing. It kind of take both into context together. And we have fewer but more meaningful results. But again, all technology support is not there yet. That's where I see the industry is going. But this is again all assessment. What about the basic security principles, the requirements? That is still important. You still have to eat your veggies, sleep well, exercise, no matter how many times you go to doctor. Next one is one more attack, which I'm going to skip because I don't have time. So once you are into AppSec program, you start with creating plan. You educate your stakeholders on security assessment types. Now the training part is over, giving them tools and technologies over. You start telling them what all different assessment types are suitable for their product, and what security checks can be automated in your CI/CD, what cannot be automated. Stuff that cannot be automated, how often we should do it. So we get everybody's buy-in. We determine the success criteria and SLA. Hey, if you knock down these high critical, then only we'll allow to production and whatnot. So you do all that good stuff. Next one is so these are the full stack security assessment that I am aware of. You can add a bunch of more stuff, but the idea here is to do security testing from end to end. Say your product has a crypto module, make sure you do crypto specific testing and not just the app level or threat modeling in this. Reporting, as I mentioned earlier, use the same bug tracking tool mechanism for recording security issues. That will help. Educate your stakeholders about subjective nature of risk. Don't just say high critical because some formula, likelihood into impact. Who is your threat agent? Your threat agent is a script kiddie, pen tester like us who has 2 weeks of timeline, or a security professor who has a team of 5 people working day and night for their next glorious paper to find this single vulnerability, or a foreign government which has army of 60,000 hackers and unlimited computational power using super. So who is that? Determine your risk for the highest threat agent and work backwards. And of course, automate vulnerability statistics, because all security professionals hate it. We don't like to compute statistics or metrics vulnerability. And again, no matter how nice the cop is or how nicely he talks to you, it never works. We always feel threatened. It's just the way our human brain is designed. So don't try to be cop when you talk to your developers about vulnerability. Try to be a doctor. Be compassionate. Tell them out of 86 attacks, your product has passed 75. Awesome, kudos. And remaining 10, we are just going to work with you together. And for some reason, they cannot fix the vulnerability because it becomes, hindrance in usability, performance. Think about innovative ways to how to mitigate that. Last one, metrics. I'm going to have a whole different presentation probably next year on metrics, but here the idea is try to speak the same language with each stack. Probably a chief security officer is not interested in granular details like how many high critical. Yes, he's interested in overall enterprise stack. Try to provide positive security metrics which will show value of your security program. For example, return on security investment. Again, that's the story of another story for another presentation. And conclusion. I'm going to read out this quote loud. If you know the enemy and yourself, you need not fear the result of 100 battles. If you know yourself but not the enemy, for every victory gained, you will lose. You will also suffer a defeat. If you know neither the enemy nor yourself, you will succumb in every battle. Very nice book. Do read it. That's the whole Purple Team philosophy, where you need to know your product inside out, and you need to know all the exploitation techniques that will be used by hackers and pen testers. So just to summarize, we have to have a holistic approach to minimize security gaps. We have to weave in security not in SDLC but in business units as well, and it always starts with security principles and requirements. Adopt security as a service, and as a security community, each one of you, I would like to urge, try to help everybody else to ease with the negative perception around security testing, and security professionals. Change is hard, and change may not happen over time, but if we continuously work together, it will happen. So with strong passion of security and perseverance for long-term goal, try to get rid of that security negative notion. Thank you, everybody.